4 minutes ago, James Webb's infrared eye caught two frozen worlds glowing with the exact same truly unknown signal. Pluto sits 3 billion miles out in permanent dark. Titan hides under thick orange haze and endless methane rain. They share almost nothing, yet somehow both are speaking one identical chemical language nobody on Earth has ever heard. Scientists checked every known molecule against decades of data. Each test still came back completely, utterly empty. So really, tell me, where's everyone watching from right now? Drop your city below, because what comes next links directly to a planet beneath our feet. Let's rewind first, because you need to see what scientists actually expected before any of this makes sense. Titan is Saturn's largest moon, wrapped in thick orange haze, hiding rivers of liquid methane and lakes cold enough to freeze steel. Pluto sits far beyond Neptune, alone in the outer dark, covered in frozen nitrogen under a whisper-thin atmosphere. For decades, researchers studied both worlds and built careful models describing exactly which chemicals belonged there. Nothing in that model left room for a mystery. NASA's Cassini spacecraft mapped Titan's atmosphere for 13 years before it burned up over Saturn in 2017. New Horizons flew past Pluto in July 2015, sending back the sharpest images humanity had ever captured of that tiny, frozen world. Both missions filled textbooks with confident, settled answers. Methane, nitrogen, tholins, the reddish organic haze coloring Pluto's surface. Every ingredient already had a name and a tidy explanation. Then James Webb arrived, and quiet certainty stopped being an option. Picture two crowds standing in different countries, speaking completely different languages, and somehow both shout back the exact same secret word at the exact same second. That's roughly the scale of coincidence scientists are now trying to explain. Launched on Christmas Day 2021, Webb carries an infrared instrument precise enough to read chemical fingerprints from billions of miles away. Back in 2023, researchers pointed it at Titan's disk, collecting spectral data nobody expected would matter much. A team led by Bruno Bazar at the Paris Observatory noticed something buried inside the numbers that didn't belong. There was a gap, a missing wavelength near 11 micrometers, sitting exactly where nothing in the published record said anything should be. Here's the part that should stop you cold. At first, the team assumed it was noise, some minor glitch nobody needed to worry about, so they checked again, then again. The gaps held its exact shape every single time, refusing to disappear. That's when someone pulled up older Webb data of Pluto, quietly archived since May 2023 and barely touched since. And there it was again, the same dip, the same wavelength, on a world 3 billion miles from Titan, with a wildly different atmosphere, temperature, and entire history. Stop and actually sit with that for a second. Two worlds, sharing almost nothing beyond a bit of methane and nitrogen, were somehow producing one identical chemical fingerprint that matches no molecule known to science anywhere. Bazar didn't try to soften his reaction. It's rather mysterious, he admitted, and that's a researcher choosing his words with real care. When someone who studies spectral graphs for a living calls something mysterious instead of explained, take that seriously. But here's where it actually turns strange, because the two signals weren't perfectly identical. Pluto's version came out roughly 3 times wider than Titan's. Same wavelength, different shape entirely, meaning whatever causes this might connect the two worlds without being the exact same substance underneath. And that detail right there, it's about to matter more than you think. Because here's the question nobody could answer yet. How does a moon soaked in liquid methane end up sharing a chemical secret with a frozen rock that barely has air at all? The honest answer is, right now, nobody fully knows. But the clues scientists gathered next start pointing somewhere specific, and it's not where you'd expect. Titan's atmosphere is thick, really thick, thicker than Earth's actually, with clouds and haze stacked for miles. So the obvious guess was simple. The signal probably comes from somewhere up in all that atmospheric soup. Researchers tested that idea directly. They compared the mystery signal against carbon monoxide, a gas already known to sit high in Titan's atmosphere. If the new signal behaved the same way, that would confirm an atmospheric source. It didn't behave the same way at all. When Webb scanned from the center of Titan's disk out toward its edge, the mystery signal actually got weaker. Carbon monoxide stayed steady the entire time, barely shifting. That's a massive clue, and here's why it matters. Light traveling through a thick atmosphere toward the edge of a disk usually gets stronger, not fainter, because it's passing through more material at an angle. A weakening signal points somewhere else entirely, the surface. Pluto sealed that theory shut. Its atmosphere is incredibly thin, way too thin to physically produce a signal this strong through gas alone. So if it isn't atmosphere on Titan, and it can't be atmosphere on Pluto, both roads lead to the exact same place, something sitting directly on the ground on 2 different worlds at the exact same wavelength. Quick gut check before we go further. If you're the kind of person who actually enjoys sitting with a real scientific mystery instead of a neat, packaged answer, drop a comment telling me which theory you'd bet on. It genuinely helps me know what to dig into next, and honestly, I read every single one. And if this channel is where you come for stories that don't get flattened into sound bites, hit subscribe now, because what's coming in the next few minutes is the part that actually connects this signal back to Earth, and I don't want you to miss it. Now, back to the surface theory, because it opens up something researchers didn't expect. If this mystery material is sitting directly on Titan's dunes and Pluto's ice fields, that means it survived conditions almost nothing survives. Freezing cold, constant radiation, and total isolation from anything resembling a normal chemical environment. Whatever this is, it's tough, it's stable, and it's apparently really, really good at hiding from every instrument humans have ever built. Which raises an uncomfortable follow-up question scientists are only just starting to whisper about out loud. What if this substance isn't just surviving out there? What if it's the exact same kind of chemistry that had to exist right here, billions of years ago, before life ever showed up on Earth? Stay with me, because this is the real reason I made this video. Early Earth looked nothing like the planet you're standing on right now. No oxygen, no ozone layer, just a thick haze of methane and nitrogen, baking under constant radiation with zero protection. Scientists call that mixture prebiotic chemistry, basically the raw ingredients that eventually got rearranged into the first living cells. And here's the detail that changes everything. Titan's atmosphere, right now, today, is made of almost that exact same recipe. That's not a metaphor, not a loose comparison for dramatic effect. Titan is functioning like a real working laboratory, quietly running an experiment that started on Earth roughly 4 billion years ago and never got the chance to finish. So when Webb found this unexplained fingerprint sitting directly on Titan's surface, scientists didn't just see a weird chemical anomaly. Some of them saw a possible snapshot of the exact building blocks that led to life itself, frozen mid-experiment, waiting patiently in the dark. Now here's the number that should genuinely stop you. The wavelength where this signal appears sits at 11 micrometers. Researchers checked that number against every molecule ever documented in published planetary science. Every single database. Every known compound humans have identified anywhere in the solar system, or on any exoplanet ever studied. 0 matches. Not close matches. 0. That almost never happens in modern astronomy anymore. Most mysteries get solved within a few years, because our instruments have gotten that precise. A completely unmatched signal, showing up identically on 2 unrelated worlds, is genuinely rare. Rare enough that researchers are now debating whether they found a brand new class of organic molecule nobody's ever cataloged before. Think about what that actually means for a second. If this compound really is connected to prebiotic chemistry, Titan isn't just a moon anymore. It becomes something closer to a preserved fossil record, except instead of bones, it's holding onto raw chemical history. And Pluto, sitting 3 billion miles further out, might be running a slower, colder version of that exact same story. Here's the part nobody's really talking about outside research circles. This single signal could quietly reshape how scientists search for life everywhere else in the universe. Not by looking for aliens waving back at us, by looking for this same specific chemical fingerprint, repeating itself on other frozen, forgotten worlds we haven't even pointed a telescope at yet. And once you realize that, the question stops being, what is this signal? It becomes something much bigger, and honestly, much harder to just brush off. Because researchers didn't stop at prebiotic chemistry. They started asking a much sharper question. Is this compound actually alive in some strange, patient, non-biological sense? Not alive like a plant or an animal. Alive like a chemical system that's stable enough, complex enough, to sit one small step away from crossing that line. Here's the number that pulled everyone's attention hard. Pluto's version of the signal came out roughly 3 times wider than Titan's. Same exact wavelength, completely different shape. Hold that thought, because it matters more than it sounds. A wider signal usually means one of 2 things. Either the molecule is mixed with other material on Pluto's surface, diluting its pure signature, or Pluto's version is chemically related, but genuinely different. A cousin, not a twin. Bizarre's team leaned toward the second option. And that idea alone opens up something researchers weren't prepared for. If 2 unrelated worlds are each cooking up their own separate version of the same base chemistry, that's not one lucky coincidence. That's a pattern. And patterns in science almost always mean there's a process behind them, something repeatable, something that could theoretically happen anywhere the right ingredients meet the right cold, dark, radiation-soaked environment. So here's the part that mainstream coverage barely touched. Researchers went back and compared the signal against samples created right here on Earth, inside laboratories built specifically to recreate outer solar system conditions. Scientists mix methane, nitrogen, and ultraviolet radiation together, then wait, sometimes for months, watching what forms. The resulting material is called tholin, a reddish, organic residue that gives Pluto and Titan their strange, rusty coloring. Tholins were already a known compound. Scientists have studied them for decades, but when researchers checked this new signal against known tholin recipes, it still didn't match cleanly. Close in some ways, not exact. That's the uncomfortable gap sitting right in the middle of this entire mystery. This substance behaves like it's related to something we understand while stubbornly refusing to actually be it. Let's actually pause and sit with that for a second, because it's easy to rush past. Scientists spent decades building laboratory versions of alien surface chemistry, got remarkably close, and Webb still found something sitting just outside every model they've built. That's not a small miss. That's a genuine blind spot in a field that prides itself on precision. And blind spots like that don't stay quiet for long. Once one team spots something this strange, other researchers start racing to explain it first, which is exactly what happened next, and it's where this story takes its sharpest turn yet. Because before any of this data ever reached Bézard's team, the exact instrument responsible for finding it nearly went silent for good. Rewind to August 24th, 2022. Engineers preparing Webb for a routine observation noticed something wrong deep inside MIRI, the same instrument built to capture this whole story. A small mechanical part called a grating wheel, the piece responsible for switching between wavelengths, started showing increased friction. Not failure, not yet. Just resistance, quietly building somewhere 100 million miles from anyone who could physically touch it. Think about that for a second. There's no repair crew floating out near L2, no spare parts, no second chances. If that wheel seized completely, an entire observation mode, the exact mode later used to find this signal, would have gone dark permanently. NASA convened an anomaly review board on September 6th. Engineers spent weeks combing through design blueprints, historical friction data, anything that might explain why a component built and tested for years was suddenly struggling in space. Meanwhile, that specific observing mode stayed frozen, unusable, while the clock kept running. Here's the part that turns this into more than a technical footnote. Saturn's polar regions were scheduled for observation using that exact mode, and they were about to become unreachable for 20 years. Not months, 2 full decades. Every day MIRI stayed offline pushed that window closer to slamming shut for good. So engineers worked the problem like a puzzle with no do-overs. They eventually concluded the friction came from tiny components inside the wheel's bearing assembly pressing together slightly harder than expected under certain conditions. Not a design flaw exactly, more like an unexpected personality trait discovered the hard way, 70 years past where anyone could just reach in and fix it directly. On November 2nd, they ran a careful engineering test, moving the wheel just enough to check their theory without risking anything worse. It worked. Friction behaved exactly the way their models predicted. 10 days later, on November 12th, 2022, MIRI's medium-resolution mode came back online, right on schedule for those Saturn observations and quietly, permanently, back in service for everything that came after, including a routine look at Titan the following year that nobody realized would matter yet. Stop and actually sit with that timeline for a second. The exact instrument that later caught an unexplained fingerprint on 2 separate worlds came within a stuck mechanism of losing that capability altogether. If engineers hadn't solved this puzzle in time, this entire mystery might still be sitting there, completely undiscovered, hidden inside data nobody could ever collect. That's not a footnote. That's the reason any of this story exists at all. Continuing exactly where Part 6 left off, the reason any of this story exists at all. So now that we know the signal survived its own near erasure, the real question comes back around, what actually is it? And here's the honest, slightly unsettling answer. Scientists are currently split between 2 competing explanations, and neither one has won yet. The first theory keeps things relatively grounded. Researchers suspect this could be a genuinely new type of tholin, related to the reddish organic material already known to color both worlds, but arranged in a molecular structure nobody's built or cataloged before. Under this idea, the signal isn't alien or exotic. It's simply chemistry doing something slightly unfamiliar under conditions Earth labs haven't perfectly recreated yet. Cold enough, dark enough, isolated enough that this particular structure never had a reason to form anywhere humans could study it directly. That theory is careful, conservative even. It fits neatly inside everything scientists already understand about tholins, just with one new variation nobody's seen. The second theory is where things get genuinely uncomfortable. Some researchers think this signal might represent something closer to a transitional compound. Not quite simple chemistry, not quite the complex molecules needed for biology, but sitting somewhere directly in between. Basically, a live snapshot of chemistry actively working its way towards something more complicated, caught mid-process, on 2 different worlds, at the exact same time. Neither camp can currently prove the other wrong. Here's why that matters so much. The tholin explanation, if true, is fascinating but ultimately tidy. A new variation of something familiar. The transitional chemistry explanation, if true, would mean researchers accidentally caught early solar system chemistry actively evolving in real time, frozen mid-step, on two completely separate worlds that shouldn't logically match at all. Bézard's team has been careful not to pick a side publicly. Published research on this signal openly states they couldn't match it against any known molecular reference in existing scientific literature. That's not scientists being cautious for the sake of appearances. That's scientists genuinely not knowing, and being honest enough to say so directly instead of forcing a tidy answer nobody's actually confirmed yet. Let's actually sit with that discomfort for a second, because it's rare. Most space stories eventually resolve into a clean, satisfying explanation within a year or two. This one hasn't, and nobody currently knows when, or if, it will. Which means somewhere between Titan's methane rain and Pluto's frozen dark, there's a compound quietly rewriting part of what we thought we understood about solar system chemistry, and right now, literally, nobody on Earth can tell you exactly what it is. That uncertainty alone should be enough to keep you here. But it's about to connect to something happening on a much tighter deadline than you'd expect. Because here's the truth nobody mentions in the headlines. Webb doesn't have unlimited time to chase this mystery, and neither does anyone competing for a chance to use it. Right now, in 2026, Webb is running strong. Engineers confirmed it launched with enough propellant for roughly 20 years of operation, and, after several years in orbit, its mirror and instruments still show no meaningful wear. That's genuinely excellent news. But fuel was never actually the tightest constraint here. Time is. Every single night, research teams around the world submit new proposals, all competing for a narrow slice of Webb's schedule. It can only point at one target at a time. One instrument, one direction, one observation running, while 100 other brilliant ideas sit waiting in line. And this Pluto-Titan mystery isn't the only story demanding attention right now. Webb's 2026 schedule already includes a broad survey of Kuiper Belt objects, the icy distant region where Pluto itself resides. Stop and actually think about what that means. Somewhere out past Neptune, in that same freezing region, there could be dozens of smaller, less famous worlds carrying this exact same unexplained fingerprint. And right now, almost none of them have ever been properly checked. Here's the part that should genuinely bother you. Every hour Webb spends studying something else is an hour this specific mystery stays unsolved a little longer. Researchers eager to run detailed follow-up observations on Titan and Pluto have to wait their turn like everyone else, competing against teams studying black holes, early galaxies, and distant exoplanets, all fighting for the exact same limited hours. So this isn't a countdown measured in years or fuel gauges. It's a countdown measured in competition, patience, and priority. A much quieter kind of urgency than a ticking clock, but a real one nonetheless. And there's a deeper question sitting underneath all of it. If the signal really does trace back toward prebiotic chemistry, every month spent waiting for follow-up observations is a month scientists aren't confirming whether Titan and Pluto are holding on to genuine clues about how life began anywhere at all, not just here on Earth. That's the tension driving research teams right now, quietly, without any dramatic press conference attached to it. A real discovery, sitting in a queue, waiting its turn behind hundreds of other legitimate cosmic mysteries, all competing for time on the one instrument capable of actually answering any of them. Which brings us to the only question left worth asking. If this signal really is a piece of prebiotic chemistry, frozen and waiting on two separate worlds, what does that actually say about how common life's building blocks might be across the entire universe? Sit with that for a second, because it's bigger than Pluto. Bigger than Titan, too. For decades, scientists treated Earth's early chemistry like a rare, almost accidental event. The right ingredients, the right conditions, all lining up once against enormous odds. But if Titan and Pluto are independently running versions of that same basic recipe in completely different environments, without any contact between them, that changes the entire conversation. It suggests this kind of chemistry might not need rare, perfect conditions at all. It might just need cold, dark, patience, and time. That reframes these two worlds completely. Titan stops being just a hazy, distant moon. It starts looking more like a working laboratory, quietly running an experiment that began on Earth billions of years ago and simply never got interrupted. Pluto becomes something similar, colder and slower, holding its own version of that same unfinished story out in the permanent dark. Here's the detail that stays with me longest. Everything happening on these worlds right now started long before humans existed, and it will almost certainly keep happening long after we're gone too. Titan's methane rain will keep falling. Pluto's frozen surface will keep sitting quietly under starlight, completely indifferent to whether anyone's watching. This mystery doesn't need us to keep unfolding. It just needs time, and it has more of that than we ever will. There's something oddly comforting buried inside that thought, and something a little humbling too. We built a telescope precise enough to catch a whisper of chemistry from 3 billion miles away, and it still couldn't hand us a clean, tidy answer. That gap between what we can detect and what we can actually explain, That's exactly where real discovery still happens. And that's genuinely rare anymore. In an era where most scientific mysteries get resolved within a year or two, this one is still wide open, still unclaimed, still waiting for whoever finally cracks it first. So, no, nobody currently knows if this is a strange new Tholen or something closer to the raw ingredients of life itself, caught mid-formation on two worlds that should have nothing in common. That question is still sitting out there in the dark, completely unanswered. And once new observation time finally opens up, we'll be first in line to bring you exactly what they find. Two frozen worlds, one unexplained signal, still completely unsolved. Maybe it's new chemistry. Maybe it's a clue about how life actually begins. Nobody knows yet. Not even the scientists studying it right now.